Okay, first of all, what is permutation? Actually, permutation is a bijective mapping from one non-empty set X into itself. Means let X be any non-empty set. A permutation on X is a bijection or bijection from X into itself. Thus, a mapping F is defined on a non-empty set X is called a permutation if F from X to X, that is the range of F, is contained in X, and F is injective, because you already know that bijective means one to one and on to both, means injective as well as surjective. Let X be a finite set on n element, that is, if X has n element x1, x2 up to xn, and let alpha be a permutation on X, then alpha of x1, it means image of x1. Here, alpha of x2, image of x2 up to alpha of xn are also element of X. Now it means we express is as alpha in first row. This is the x1, x2 element of x1, x2 up to xn. And in second row, image of x1, this alpha of x1, image of x2 is image of x2, and up to xn, image of xn is alpha of xn. Now, example, let X has element from 1, 2, 3, and 4, and alpha be a permutation on X defined by, here image of 1 is 2, alpha of 2 is 1, it means image of 2 is 1, alpha of 3 is 4, alpha of 4 is 3. Then we express it as, now in first row, same element of X is 1, 2, 3, 4. Now what is image of 1? Means what is alpha of 1 is 2. Here is in second row, first element is 2. Here what is image of 2? Means alpha of 2 is 1, it means 2. What is image of 3? Is 4, it means 4. Here image of 4 is 3, is written as 3. And the same permutation can also be expressed as, here it means you already know that in set order is not problem. If you write 1 2 3 4 or 3 2 1 or 3 4 1 2, these are all are the same. It means in permutation in first row, because first row representing the element of X. That's why if you write 1 2 3 4, or you write 4 1 2 3 or 3 4 2 1 or 2 4 3 1, these are all the same. Please don't write anything on this page, please. Okay, see here, this example I told before you, this is alpha, If you write here 1 2 3 4 or 3 4 2 1 or 2 4 3 1, these are all the same permutation because their is always same. See here in first permutation, what is alpha of 1? Image of 1 is 2. Here is also image of 1 is 2. What is image of 2 1? Image of 2 is 1. Image of 3 is 4. Is 3 is 4. Same again here. What is image of 1 is 2. Image of 2 is 1. Image of 3 is 4. And image of 4 is 3. It means no problem. In first row of any permutation, you write in 1 2 3 4 or 4 through 3 1 or 3 4 2 1 is no problem. Now what another is identity permutation. What is identity permutation? It means one is map is 1, 2 mapping 2, 3 mapping 3, 4 is mapping 4. It means f of x equal to x or I of x equal to x. Such type of permutation is called identity permutation, same like identity function. And equality of two permutation, let x be any non-empty set, two permutation alpha and beta on x are said to be equal if their image is always equal. Means alpha of x equal to beta of x for all x belongs to x. X is a non-empty set. Now product of two permutation or composition of two permutation, if you multiply alpha composite beta of x, the same concept of composite function here, alpha and is a beta of x for all x belongs to x. If beta composite of x means beta and alpha of x. If you need to find alpha composite beta, then first you find beta of x, take image, then you apply alpha. Take example, here S is element 1 2 3 4. We have two permutations, alpha and beta. Alpha is this, beta and this. Now we need to find alpha composite beta. Now alpha composite beta means here alpha beta of 1 because both have same domain 1 2 3 4. What is image of 1? Here alpha beta of 1, it means alpha beta of 1. And now beta of 1 is 2. See here, beta of 1 is 2. It means in place of beta 1 you write 2 and this alpha is same. Now what is alpha of 2? See here, alpha of 2 is 3. It means image of 1 is 3. And similarly, if you take the second element, beta of 2 is 4 and alpha is 4 is 1. It means image of 2 is 1. Again, beta of 3 is 3 and alpha of 3 is 2. It means image of 3 is 2 and image of 1 is 4. Now we have new. Simply see here, alpha beta means take this from this side. What is image of 1? 2. Okay. Now see here, what is image of 2 is 3. It means 1 goes to 3. 2 goes to 4. 4 goes to 1. It means 2 goes to 1. 3 goes to 3 and 3 goes to 2. It means 3 goes to 2. 4 goes to 1, 1 goes to 4 is 4. This is a product of alpha and beta. Similarly, you can find product of beta into alpha. This is beta into alpha. Again, we take first alpha here. Image of 1 is 4 and 4 is 1 is 1. 2 is 3 and 3 is 3 is 3. 3 is 2 and 2 is 4. 4 is 1 and 1 is 2. Means 4 is 2. Now this is non-commutative group and that's why in journal alpha beta not equal to beta alpha. The product of two permutation can be calculated and another way to calculate alpha into beta. And I told you before in last lecture in class, is depend upon you. You apply product from left to right or right to left, no problem. But you should mention first. Now, here symmetric group or group of permutation. When suppose we have any non-empty set X and then we apply, we find all possible permutations on X and make a set of all permutation with composition of composition of function, then it form a group. It satisfy all property of the group, means combination, collection of all permutation on X. Now here's a theorem: let X be non-empty sets and A sub X be set of all permutation on X. It means collect all possible permutations on X. Then this set is represented by S sub X is a group under composition of mapping as a binary operation. Here a binary operation is composition of mapping. It form a group. It satisfy all properties of group. It's closure, associativity, and identity, inverse of each element, but it's not commutative. Proof of this theorem is given here, is very easy. You do yourself. And this A sub X is a group. It is also got symmetric group on X or group of permutation and X. Now in a special case, when X equal to n, we write here Sn for X. Sometimes we also write this X sub n in place of A sub X, and called symmetric group of n symbols. N symbol means total number of element present in X, or symmetric group of degree n. It is also denoted by Pn. Clearly Sn consists of n factorial elements. If X has 3 elements, then A sub n must have 3 factorial permutations. Means total number of element in A sub n is 3 factorial. It means 6. And every element is a mapping. Every element in the A sub n is a mapping or function. There are 6 mapping, different mapping. The order of the group Sn is order of Sn is n factorial. Okay. Now symmetric group of S3. S3 means the 3 element. See here. Here S equal to X, 3 element means maybe X1, X2, X3. Then S sub n means there's 6 permutation identity. This is you say delta 1 or any symbol P1, P2, and P3. Now we have 6 different permutation formed from X whose 3 elements 1, 2, and 3. Now see here, these all permutations are different. Now using composition table or Kelly table, you can prove that this is a group. Now if you multiply this, it means Kelly table 36 elements, multiply 36 permutations, and then you multiply by identity, and then you multiply by sigma 1 multiply by sigma 2. You can practice it. Now from the above table, we can identity is a permutation Sn in S3. It means identity element present here. And from this table, you can show that also clear property satisfy no any element out of this set in S3, and S3 is not commutative. The inverse of element also present here. See here, it means when we multiply 2 elements, result is identity. It means both are inverse to each other. Here sigma 2 inverse of sigma 2, sigma 1 p inverse of sigma 1, and all inverses also present. If you take only 3 elements, identity sigma 1 sigma 2 itself form a group. This is another definition. When we go further, when we find even and odd permutations, then this is actually the set of all even permutations. Set of all even permutations again form a group. Actually this group is called alternating group, and the subset of S3. Okay, these all the all property of group are satisfied. It means this form a group. Now another cyclic group. Let S be any non-empty set. A permutation alpha on S is called a cyclic permutation, or cycle if there exists a finite set a finite subset x1, x2, xr of S such that alpha of x1 is x2, alpha of x2 is x3, alpha of xr minus 1 is alpha xr, then alpha of xr equal to 1. And it means this is a cycle starting from x1 and ending up to x1, but there must be some element, they are fixed, just like alpha of x map to only alpha of x. If x belong to S, but this x not belongs to this cycle, then such type of permutation is called cyclic permutation. In cyclic permutation, alpha defined above is denoted by alpha equal to x1, x2, xr. It means alpha denoting one cycle which is start from x1 and ending up to xr. But you know that in x, not r element, there are n element, maybe one, at least one or more than one element are fixed, which is not representing in this cycle. When a cyclic permutation alpha represent as given above, then the number of elements then appear in such a type of representation is called length of the cycle. It means how many elements are in r, it means length of cycle is r. Now see here in example 3, here 7 element in S. Here alpha is a permutation on S defined by this way. Okay, and now see here 1 goes to 1, this is a fix. 2 goes to 2 is also fixed. 4 goes to 4 is also, means 4 element are fixed. No, 1 goes to 1, 2 goes to 2, 4 goes to 4. 3 element are fixed, but 3 goes to 5, 5 goes to 7, and 7 goes to 3. One cycle which is start from 3, 5, 7, 3, 5, 7, but again other 4 element are fixed. It means this is alpha equal to 3, 5, 7, because 3 goes to 5, 5 goes to 7, and 7 goes to 3, and other element are fixed, and fixed elements are 1, 2, and 6. Also, what is the length of the cycle is 3. First observe that alpha is now 3, 5, 7, or you simply write 5, 7, 3 or 7, 3, 5, no problem, because this is outset. Now some element are fixed, because we are saying that alpha belongs to S7. It means they have 7 elements. In a first row, we must write 1, 2, 3, 4, 5, 6, 7. And then we have one cycle 3 to 5, 5 to 7, and 5 to 3, and other elements are same. Again, you take another example. Now here B, and B is not a cyclic. Why? 1 goes to 2, 2 goes to 3, 3 goes to 4, 4 goes to 1. Again 5 goes to 6, 6 goes to 5, 7 goes to 8, 8 goes to 9, 9 goes to 10, and 10 goes to 7. It means there is no any element like this alpha of x equal to x. All are these cycles, but in cyclic permutation there should be at least one element like this way, means fixed alpha of x equal to x, but there is no any such type of x. That's why this is not cyclic permutation. A cyclic permutation of length 2 is called transposition. Now here, what is the length of cycle in above example? Example number 3 is 3. Now if any cycle whose length is 2, only 2 element, such type of cycle is called transposition. Here order of the permutation, order of the cycle. The order of the cycle related to length, which can be observed from the following. Suppose your alpha is 3, 7, belongs 7. Clearly, what is alpha? Alpha is 3. Because alpha of 3 is 5, alpha of 5, 7, alpha of 7 is 3, and some element are fixed. If x belongs to 1, 2, 3, 4, 5, 6. And easily you can check how to find the alpha of 3 is 5, and alpha square of 3. It means alpha square means alpha into alpha of 3, and alpha of 3 means 5. Then alpha of 5 is 7. Again, alpha cube is 3. Alpha cube means alpha into alpha square 3, and alpha square is 7. It means alpha of 7 is 3. It means you starting from here, starting from 3, and you get here again alpha cube of 5 is 7. It means this also alpha cube of x is x for all x belongs to 1, 2, 3, and 4. It means alpha of x हेलो आवाज अच्छे पे मुझे तांगे सही हेलो
जी जी सर
अच्छे पे
जी
आवाज
सर बिल्कुल
अगर आवाज प्रॉब्लम हुजे न मूंखे तव्हां टेक्स्ट करे छॾिजो ठीकु आहे
सर इलाही छोकरा कनेक्ट न पिया थियनि
कुझु रहियल हुआ मूं कनेक्ट कया नहीं हींअर वरी
चलो सही आहे ठीकु आहे
ठीकु आहे अच्छा आऊं तव्हांखे जेको आहे म्यूट न पियो कयां मगर प्लीज़ ॻाल्हाइजो हुन विच में
Okay, sir.
ठीक है if alpha belongs to Sn is a cycle of length k then order of alpha is k ठीक है alpha belongs to Sn is a cycle of length k means alpha is cyclic permutation of length k then order of alpha is also k means same order ठीक है the proof of this theorem is already proved do yourself again disjoint cycles what is disjoint cycle two cyclic permutation alpha and beta in x sub x are said to be disjoint if every x belongs to x is moved by one permutation is fixed by another it means disjoint cycle means if suppose you have two cycles one cycle is 1 to 2 and 2 to 1 is a cycle of length 2 another cycle 5 to 4 and 4 to 5 it means there is no any common element in both cycles such type of cycle is called disjoint and composition or a product of two disjoint cycle is commute in general permutation is not commutative if two cycles are disjoint then product of two cycles are commutative. This is a very important theorem. Product of two disjoint cycles are commutative. I'll take example. Here alpha, see here, alpha is 1, 3, 5, belongs to 5, and beta is 2, 4. See here, there's no any element common in both cycle. Here's 1, 3, 5, here's 2, 4. Okay. Now show that alpha product beta equal to beta product alpha. Now multiply this, we get this. The product, you already know how to product two permutation. And beta alpha is same. It means both are same. If cycles are disjoint, then they are commute alpha beta equal to beta alpha. If alpha and beta are two cyclic permutation but not disjoint, then product is not necessarily commutative, which can be seen from the following example. If cycles are not disjoint, then their product not necessarily commutative. Here is alpha, beta. See here is a 3, here is also 3. It means not disjoint. Then you find alpha and beta. Both are not equal. Here is alpha, beta and beta, alpha. It means both are not equal. And another result, let X be a finite set and alpha be any permutation on X. Then alpha can be expressed as product of disjoint cycle alpha beta 1 beta 2 beta k, that is alpha equal to this, each of length 2 or more. Further, this representation is unique except for the order of this. It means if X is any finite set of alpha, means any permutation on X can be represented as product of disjoint cycles. It means you take any permutation, and any permutation alpha can be represented as just like B1 product B2 up to Bk, but each length is at least 2 or more than 2. Okay, means any permutation can be represent product of disjoint cycle. Now see here in example number 6, express alpha as a product of disjoint cycle and find also inverse. Now here 1 goes to 3, 3 goes to 4, 4 goes to 2 and 2 goes to 1. Now orbit related to 1 is this. Here 5 is not in the orbit of 1. Now here 5, 7, the remaining element is 6 whose orbit is 6. It means alpha equal to 1, 3, 4, 2, 1, 5, 7 and 6. And again here is a 6. It means every cycle must be length is 2. Okay.
अयाज माइक बंद करो अयाज.
Here length is 1. Here is 1, 3, 4, 2 and 5, 7. Now alpha can be represented product of disjoint cycle. There is no any common element in both cycle, and any cycle of length 1, no need to write. These are the fixed element is same. And find the inverse, also inverse of alpha this. It means you take inverse and you get again 5, 7 and 2, 4. And you already know how to find the inverse. First to convert these cycles in a permutation, and then you usually find the inverse. And every transposition is its own inverse. What is transposition? Transposition is any cycle of length 2. Means every transposition is its own inverse. On inverse means alpha into alpha equal to I. It means alpha inverse equal to A. Thus every transposition is its own inverse. Now let X be a finite, theorem number 6. If X is any finite set, the order of the permutation on X is the least common multiple of order of this cycle. If we have one cycle, then order of the permutation is very easy, number of element. If we have many cycles, then how we find the order? Then if we have 2, 3 cycles, then we take LCM of these cycles. The order of the permutation of X is least common multiple LCM of order, and its order of its disjoint cycle. Because in above theorem you already know that any permutation can be represent product of disjoint cycles. First you write any permutation disjoint cycles, then you take LCM, LCM for all cycles. This is called order of the permutation. And order of the permutation of finite set is LCM of length of its disjoint cycle. See example number 7. Now the alpha is product of the disjoint cycle, means is a B1, B2 and B3. Now B1, B2 and B3, what is order? LCM length of disjoint cycle. Length of B1 is 4, length of B2 is 3, length of B3 is 3. Take LCM of 4, 3, 3 is 12. It means here, what is the order of this? Is 12. Every permutation of finite set is product of transposition. Every permutation of finite set is product of transposition. With the same theorem, follow from same theorem, any permutation can be represent product of disjoint cycles. But what is transposition? Transposition is again cycle of length 2. It means every permutation